Well, good afternoon, folks. Welcome back to Don's Radio Lab. Messing around with my HP 8594E spectrum analyzer. And what we've got going on here is you can see that there's a calibration error, and I'm going to have to go in and either align it or repair it. Let me try zooming out here a little bit. Go, and I apologize about the heater. It is about 36 below zero out there, and it's pretty cold. So anyways, this is my spectrum analyzer. Once it's going and functional, it will be probably the absolute centerpiece of my laboratory, my bench. So it's kind of important that this gets going. What is a spectrum analyzer? It differs a little from an oscilloscope, where an oscilloscope gives you a voltage on the vertical axis and time on the horizontal axis. This gives you voltage on the vertical axis and frequency on the horizontal axis. And so what we're showing here, usually these are set up as far as your center frequency and then a span on either side of that. And so we have a voltage there, see, center at about 300 megahertz. Let's see here, if we go to just let's see here. Now, if we just turn it back on, reset it, it should show, this is the calibration data, and it's showing little peaks at different frequencies across there. Well, anyways, here, let me reposition the camera here, and we'll take a look at the inside. Okay, what we're looking at here, these HPs were just fantastically engineered. This thing is built like a tank. In this area here is the CRT, power supply here, and some of the processing boards. Here I've got a couple of the options installed. Let's see here, the narrow bandwidth and the TV sync, the TV trigger sync. And then here we have our filters and amplifiers, and then all the access points in which we would calibrate this thing. Oops, sorry about that. I've had to go through and build a few of these, which are just a resistor and a capacitor in there to short out some of these test points, and I've tried to calibrate this, and it didn't work out. So what I'm doing now is watching a bunch of videos and reading the very hefty manuals, the user manuals, the service manuals. There's about 4 or 5 500-page manuals that go along with this thing, and like I said, once this thing is up and going, it is just the absolute centerpiece of all of this equipment here. So there again, like I said, it's important that this gets going, and it is a very complex piece of equipment. So it may take a little time, but you know, I got it for pretty cheap on eBay, and the furnace is going to go again here, so I apologize. It's super cold outside. So like I said, this is kind of what I've been up to the last couple days that I've had off, and that I can take a minute to look at a few things. So let's see here. Okay, we're looking at the oscilloscope here, signal generator here. Here I'm set out to put 1 kilohertz into the oscilloscope just as a test frequency here will enable the output, and then there we can see our oscilloscope. Again, we're seeing the difference in voltage over time. We're putting out 50 millivolts peak to peak, and let's see here, we are set to there. Each graticule box is 20 millivolts. So we're actually showing 100 millivolts. That's weird. I probably need to put this in through a 50 ohm termination because we're getting double the output. So I have this signal generator set up for 50 ohm output. Let's just see what happens when we change this back to high Z. Nothing. That's odd. That should change the output. There again, let's go back. Huh. Well, there's something going on that I need to look into. That should change the amplitude of the wave or the size of the vertical deflection there. Anyways, so we can do that here just by varying the amplitude, and so as we turn the amplitude down, you can see the wave gets smaller, and then if we alter the frequency, we can see that these peaks get closer together. So there we are, we're looking at voltage over time, whereas the signal generator or the spectrum analyzer down below is looking at frequency on this horizontal axis. So we are looking at a signal in two different domains, and it kind of helps us make adjustment. If we're working on a transmitter or a receiver, we can tune filters, or we can adjust the parameters of the transmitter. So the spectrum analyzer is really helpful if you have a transmitter, making sure that all the power you're putting out is on the channel within the bandwidth that you want it to be, and that you're not putting any power out outside of what would be the channel. There you go. Okay, we're looking at my Tektronix 2465 analog scope, and we're looking at the same 1 kilohertz signal at 50 milliamps peak to peak, and here we're showing that our graticule, or our vertical deflection here is set up for 20 millivolts peak to peak, and you're counting 5 boxes, which would be 100 millivolts. And so when you're putting signal out of your signal generator, you need to make sure that all the input and output impedances match. And so right now the signal generator has set up to output into 50 ohms impedance, and the signal, or the oscilloscope here, has 1,000,000 ohms. But what we can do here is just we can put this into 50 ohm input, and there you can see that the size of the signal has decreased by half. And so there must be a setting on my digital scope that I need to look into the manual a little deeper to see how I can set it up for 50 ohm impedance. Well, here we go, folks. I don't know if this will show up that well or focus or what have you, but what we're looking at here, let's try zooming in on it. The price in 1992 was $14,995, and then why here one of the options was $26.25, and then another $650 for the interface, and there's another option that's not even listed here. So yeah, this was a serious piece of gear back in the day. Yeah, we're happy to have it. And there again, like I said, I don't think I paid 1/30 of that price. Hopefully all it takes is just a little bit of love to get it up and going, and or just a few minor repairs. This came without the optional tracking generator, and if I could find one for this, I have a slot available still right here, and then there's some other gear that goes with it, and then I'd have an output here like that. That would probably double the functionality for this thing. This is an analog spectrum analyzer, so when you what you're looking at is real time. Digital spectrum analyzers, I mean, they're great. They do a lot of things, but everything's all calculated, so it's not exactly real time unless you buy a really unless you're spending the kind of money it would have took to buy this thing brand new in 1992. For what I'm doing, a lot of times the analog stuff is better. So, this is still a very functional, very useful piece of equipment, even though it is older. Like I said, it just needs a little love. We'll try to get it going, but in the meantime, I'm going to have to do some serious research, a lot of watching videos and a lot of reading manuals.